Antimatter, which is worth up to $62.5 trillion per gram, and it is one of the world's rarest substances. There is an imbalance between regular matter and antimatter in our observable universe. After all, what is the reason for all this? So today we are going to know about antimatter from its historical context to the production method in this video. Antimatter is a concept in particle physics that refers to particles that are similar to regular matter but have different charges and other quantum properties. In particular, antimatter particles and their corresponding matter have the same mass but different charge or disordered quantum numbers, such as spin. For example, electron carriers are called positron. It has the same mass as the electron but it carries a positive charge. The historical context of antimatter dates back to the 20th century, when scientists were making major discoveries in the field of particle physics. We will discuss some of these important moments. Number 1. Direct equation. The theoretical foundation of antimatter was laid by Paul Dirac. He developed a new equation which combined quantum mechanics and special relativity to describe the behavior of electrons. This equation predicted the existence of a solution of negative energies, later interpreted as antimatter particles. Number 2. Discovery of the positron. The first antimatter discovered was the positron. Carl Anderson observed that when electrons in a cloud chamber were exposed to cosmic rays, the electrons curved in the opposite direction. Cosmic rays are positively charged. When electrons are exposed to them, they curve in opposite direction due to repulsion. This proves that there is also a positively charged electron, mean positron. Number 3. Antiprotons and antineutrons. In experiments at the Beaverton Accelerator at Lawrence Berkeley National Laboratory, antiprotons, antiparticles of protons, and antineutrons, antiparticles of neutrons, were produced for the first time. This confirmed that the existence of antimatter other than electrons and positrons. Number 4. CP violation. The issue of antimatter has become deeply related to the question of why there is more matter than antimatter in the observable universe. This has led to the discovery of a CP violation. CP violation is a phenomenon that involves a violation of the combined symmetries of charge configuration and parity. Such is believed to be a factor in the disequilibrium of matter and antimatter in the observable universe. Research in CP violation is important to understand the imbalance between matter and antimatter in our universe. Number 5. Development of antimatter production techniques. Over the years, scientists have developed many ways to create and manipulate antimatter in laboratories, which includes the use of particle accelerators and sophisticated experimental setups. Number 6. Modern advance in antimatter research. In recent times, advance in technology and particle physics have allowed precise experiments with antimatter. On 27 September 2023, CERN researchers observed that individual atoms of antihydrogen were falling due to the effect of gravity. This confirms that antimatter and regular matter are gravitationally attracted. This shows that the world is getting interest in antimatter. In general, the production of antimatter involves the creation of particles that have the opposite properties of regular matter. This process usually requires a powerful particle accelerator to generate high-energy particles, which are then sent into the target material. The target material is the specific material that is placed in the path of the high-energy particles, and they collide with the target material, resulting in the formation of antimatter particles. Once created, antimatter is carefully contained by magnetic fields or other methods to prevent it from coming into contact with regular matter, which can eliminate antimatter. This process is extremely difficult and resource intensive, making antimatter one of the rarest and most expensive substances on the planet. The future of antimatter research is significant for theoretical advancement and practical applications. What the future holds for antimatter research? Here are some important aspects. Number 1. Applications in medicine. Advance in antimatter research can play an important role in medical science. For example, improvements in positron emission tomography technology may increase our ability to diagnose and treat various medical conditions. Number 2. Improved production and storage techniques. Scientists are constantly working to improve how to produce and store antimatter more efficiently. This includes developing more advanced particle accelerators and advanced trapping techniques. Number 3. Potential for energy production. However, its use is highly challenging. Antimatter could potentially be harnessed as an extraordinarily efficient energy source for space travel, and research into this could lead to a unique propulsion system. Number 4. Quantum computing and information processing. In advance in quantum computing and information processing technology, the unique properties of antimatter particles can be potentially be exploited. Antimatter research is focused on improving production technique, performing accurate experiments, and exploring potential applications in medicine and high energy physics. So this was today's video. How did you like this video? And if you like this video, please subscribe to us.